Hi all, so this is lecture 28 of ME221 and today we'll be discussing about polar calculus. So the two things that uh, I'll discuss is polar area, how to calculate that, and how to calculate the arc lengths of a given polar equation. So our goal in this lecture is to find the area or the region bounded by a polar curve, say r given as a function of theta, and theta varies from a to b. So this is the curve, and the rays theta is equal to a and theta is equal to b. Okay, so this is the curve, r is equal to f theta, and these are the rays. This is, say, the ray theta is equal to a, and this is the ray theta is equal to b. So basically, I'm interested in finding this shaded area. Okay, so we know that when we have a question about finding area, what we do is we try to take a small segment or a small wedge and try to estimate that. So say this is the a very small wedge of the uh, of this total area. So, and say this shaded region is like dA. This is the radius r, and this angle is theta. So this angle is d theta, sorry. Okay, so the area of this wedge will be d theta over 2 pi times area of circle of radius r. So d theta over 2 pi will be proportion of a whole circle, right? Because if you consider the circle of radius r, then the whole area of this circle is 2 pi, right? So if I consider this small little, uh, pizza slice or whatever you might call it, having the angle d theta, then this d theta over 2 pi is the angle when we consider this small pizza slice. And the total area of the circle of radius r will be pi r square. So ultimately, I have d theta over 2 pi. So this is coming from this picture when we consider the small pizza slice. So this is nothing but half pi r square d theta. Oh, there's no pi, sorry. This will be half r square d theta. Okay. So the total area will be, I have to take the integration because I have taken a small portion, right? So if I consider the whole region, then my total area will be integration from a to b half r square d theta. Okay, this is the expression that I need later. Okay, let me. Okay, now if we look into this example, so in this example, we are asked to find the area contained inside the centroid r is equal to 1 plus sine theta, where theta is varying from 0 to 2 pi. So this is the picture of the centroid. Okay, this is your centroid. Now I have to find the area, right? The formula for area will be 0 to 2 pi, then half r squared d theta. But I have the expression for r given as 1 plus sine theta. So I can basically replace that. Then I'll have half 1 plus sine theta square d theta, right? But this is nothing but 0 to 2 pi half plus sine theta plus half sine square theta. When you factor this half inside and you use the formula for a plus b whole square, you'll get this expression at the end. And this, for this integration, we have to use the reduction formula. Okay. So for that, I'll have theta over 2 plus, actually minus cosine theta, and then I'll get half times minus sine theta cosine theta over 2 plus integration half theta, and it should go from 0 to 2 pi. Okay, ultimately I'll get 3 theta over 4 minus cosine theta minus sine theta times cosine theta over 4. And the lower and upper limit are 0 and 2 pi respectively. So at the end, I'll get 3 over 4 times 2 pi minus 0 plus 0 minus 0 plus 0. Okay, so it'll be 3 pi. Oh, sorry. It will be 3 pi over 2. So this is the area of that shaded region inside the centroid. Okay, for the next example, the question is kind of similar. You have to find the area of the of one petal of the rose r is equal to 3 sine 4 theta. Okay, so when you see 4 theta, in your mind, you should think like it should be a 8 petal rose sort of structure. And the other way to see it is when you take r is equal to 0, then you'll get sine 4 theta to be 0, right? And then 4 theta can be any of these values, and theta should be either 0 or 4 pi, pi over 4 or pi over 2 and so on till you hit 2 pi. So this is nothing but 2 pi. Okay. So at all of these points, your distance from the origin will be 0. In other words, like, sorry. So at pi over 4, at 0 or pi over 4, you will be at origin. Okay. So if you try to draw it using a graphing calculator or manually, you will get you'll get this sort of 8 petal rose structure. Okay. So now the area of one petal, so therefore I'm only interested in one of this petal. So it will be this formula, but theta will be going from 0 to pi over 4, right? Because this petal, this first petal, is when theta is pi over 4 and 0. Okay. So therefore, your range will be 0 to pi over 4, and then half r square will be just 3 sine 4 theta square, right? Because I know that r is 3 sine 4 theta. Okay, then try to simplify the expression. You'll get 9 over 2, 0 to pi over 4, sine square 4 theta d theta, right? And then you can take the substitution as u to be 4 theta, then du is 4 d theta. And accordingly, you have to change the upper and lower limits. When your theta is 0, your u will be 0. When your theta is pi over 4, your u will be pi. So therefore, you'll get 9 over 8, 0 to pi, sine square u du. Okay. So this is something you have already seen many times. Therefore, I'm not going through it very thoroughly. And again, you have to use the reduction formula, and then you'll get half sine u cosine u plus half u 0 to pi. And then when you put the upper and lower limits, you'll get 0 plus pi over 2 minus 0 plus 0. So you'll get at the end the answer as 9 pi over 16. Okay, cool. For the next example, again, you have to find the area, but this time the region is the region should be inside the circle r same as 3 sine theta, and outside the cardioid r is equal to 1 plus sine theta. Now, this is a cardioid. Okay, if you try to draw it, and that is a circle. Okay, so if you try to read the example again, we are basically asking what is area of this shaded region. Okay, so first thing is you have to find this intersections, right? Because this will be your upper and lower limit at the integration. So at this point, at these 2 points, these two curves, the centroid and the circle, are intersecting. So therefore, to find this two intersecting points, I have to do the I have to take the equal I have to equal these two things, right? 1 plus sine theta and 3 sine theta. Okay. So this was coming from there, that was coming from there. Okay. But then if I try to simplify it further, I'll get 2 sine theta to be 1 and then sine theta to be half. Now, I then figure out that theta should be pi over 6 or 5 pi over 6. Okay. Because these two are values of sine theta. See, these 2 points are obviously in between 0 to pi, right? So theta should be from 0 to pi. And these two are the only values of sine inside this range, 0 to pi, such that sine theta is half. Okay. So therefore, I mean, these two will be the only values. So I got this point as pi over 6 and that point as 5 pi over 6. Okay. Now the formula for area is quite easy now, but this time I have to take half 3 sine theta squared d theta minus 5 pi over 6 to pi over 6 to 5 pi over 6 half 1 plus sine theta square d theta. Okay, I need to subtract this. I need to subtract this expression from this. Why? Because you can see that this is the upper curve, right? So therefore, I have taken it. So this integration will be bigger, right? Because this is the upper curve. And then you have to subtract the lower curve from it because, you know, this is the lower curve, right? Sorry, this is the lower curve. So therefore, I had to take integration of this curve minus integration of the lower curve. Okay. That is why we are getting this expression. We have to subtract one from the other. Okay. And the rest is like easy to do because basically you just need to do this integrations. Okay, so I'll leave it to you. For the next example, you have to find the points of intersection of the polar curves r to be 2 sine 2 theta and r to be 1. Okay, so r is equal to 1 is the circle, uh, is this circle, right? Which is drawn in a red line. So this is r equal to 1 and r is equal to 2 sine 2 theta will be this 4 petal rose. Now I have to find the intersection points of this two curve. Okay. So the same thing for this also I need to equate both of the expressions, right? And then I'll get sine 2 theta to be half. Okay. So 2 theta can be pi over 6, 5 pi over 6, 2 pi plus pi over 6, 2 pi plus 5 pi over 6, and so on. But I need my theta to be inside 0 to 2 pi. That's why I'll only consider all of these values. Pi over 12, 13 pi over 12, and then 17 pi over 12. The next number after this will be 25 pi over 12, but that is bigger than 2 pi, right? My theta should be inside 2 pi, so that's why I should not consider the last term, okay? So these are the 4 points. And if I try to indicate these 4 points, these 4 points will be this, rather I'll choose this. This is the first point, this is the second point, this is the third point, this is the fourth point. But I can see there are 4 more points. This using, I'm using the, let me use something. Let me use the green. So these green points are also points of intersection, right? So one, very natural question would be why those 4 green points are not included in this? Because the other 4 points are coming from r is equal to -1, okay? R is equal to -1 is also this same red circle, right? If you remember it correctly. So then if I equate r is equal to -1 and r is equal to 2 sine 2 theta, then I'll get sine 2 theta to be -1 over 2. And then my possible values of 2 theta will be 7 pi over 6, 11 pi over 6, 19 pi over 6, and 23 pi over 6. I will not include anything else because then if I consider anything after that, then my theta will be outside the range of 2 pi. So therefore I'll get 7 pi over 12, 11 pi over 12, 19 pi over 12, and 23rd pi over 12. These are the other 4 green points, okay? Okay, so that is all about area under polar curve. The next thing would be how to calculate arc length. So if you have one polar curve given as r is equal to f theta, theta is in between a and b, and say this is the graph of that curve, then I can use the parametric formula, okay? I know what is the expression for arc length when you have parametric equations. So I know that x is equal to r cosine theta and y is equal to r sine theta, right? This is the, interoperability between polar system and Cartesian system. These two equations was there when we discussed about those things. But I know this time that r is equal to f theta, right? So I can replace r as f theta cosine theta and here as f theta sine theta. Okay. Okay. Now, if I use the formulas of arc length, which we discussed in parametric equations, then I know that there we have this formula for, arc length. Just that instead of theta, there was t or something, other parameter, okay? But, theta is like a independent variable, just like t. So it doesn't matter if I use theta or t, both are the same thing. So basically I have to calculate, I have to simplify this expression now using several, other formulas that we have. Okay, so what is dx over d theta square plus dy over d theta square? This is the formulas of x in terms of theta. So I have to take derivative of this 2 with respect to theta, and then I'll get f prime theta, product rule. I need to use cosine theta minus f theta sine theta. Basically, I'm using this expression and taking the derivative of it, square plus f theta, f prime theta sine theta plus f theta cosine theta square. And this is coming from there. Okay, cool. So far, so good. And now Now, if I again use the formulas for a minus b square whole square and a plus b whole square and try to simplify it further, I'll get f prime theta square times cosine square theta plus sine square theta, and f theta square cosine square theta plus sine square theta. Okay, so this is same as 1, this is same as 1, so therefore I'll get f prime theta square plus f theta square. Okay, cool. But then I need a little bit more space. Just a second. Okay, cool. But then the ds will be just square root of f prime theta square plus f theta square. Okay, d theta. So arc length expression for polar curve will be integration ds, which is a to b square root of, so f theta is r, so I'll get r square plus f prime theta. So what is f prime theta? I know that f theta is r, so f prime will be dr d theta. I'll get dr d theta whole square. Okay, and there should be a d theta at the very end. So this is the expression for arc length. Now, okay. Now if I try to use the formula in the following example, then what will I get? Okay, so the next example is you have to find the length of the spiral r is equal to theta, where theta is varying from 0 to 2 pi. Okay, so so this is the graph of the spiral, as you can see. If I use the formula for r is equal to theta, then dr d theta will be 1. So ds will be square root of f prime theta. So I'll get r square plus dr d theta square and d theta at the end. So this is the expression for ds. So my arc length will be integration ds, which is 0 to 2 pi integration 1 plus theta square d theta. Okay. Now, to evaluate this integration, you might recall that we have to use either substitution as theta to be tan u, or there's a straight away formula to evaluate this sort of integration. So I'll use the formula rather to evaluate it. So according to the formula, I'll get the integration, the value of the integration as this. Okay, the limits are 0 to 2 pi. And then if I evaluate at 2 pi and 0 respectively, I'll get my final answer as pi times square root of 1 plus 4 pi square plus half ln 2 pi plus square root of 4 pi square plus 1. Okay, so this will be the arc length of the polar curve. And this is it about calculus of polar curves. I hope you'll be able to solve the problems in homework 7 now. And this is probably the final lecture of the course. Okay, I hope you will be able to do good in the final exams. And in between, if you have any questions, queries, either you can mail me or ask me for some time to discuss. Okay, cool. Thank you.